Okay. Hi, Mark. You're muted. Okay.
Oh,
I'm not quite sure why my video isn't working, but see if I can make that work. Back a minute.
Hello.
Yay.
Hey, everybody. Good morning, good evening, good afternoon.
Afternoon. Thank you, Mark, for liking my blog post today.
well, I mean, it's
kind of a no-brainer, right?
well, it is, but tell that to regulators in certain parts of the world that absolutely insist on lawful intercept.
Yeah. Lawful intercept's a bit different. But yeah, no, okay, in this context. Yeah, no. Yeah,
Like, we have to deal with this. Like, we need to also break and inspect proxies are high on every IT administrator's mind in the regulated industry. Like in our case, basically, regulators want to know what the traders are talking about. They mandate that you use some modes of communications, but not others. So, you know, it's aspirationally, I'm with you.
Yeah, I get it. I'll put it in the link just in case someone's interested.
So I don't know what the agenda today is. I was hoping to walk the group through a more detailed presentation of what I was going on about last time we met 2 weeks ago when we were talking about attestation governance patterns. So our group has prepared a drill down and it's 10 slides long. Should not take more than 20 minutes, but I think we talked about doing it at this gathering, but I just don't know if this was ever confirmed as a agenda item.
Yeah, I think when we left last week, the only thing on the agenda when we left was any sort of follow-up you wanted to do, Mark.
I do want to do a follow-up. Yeah.
Yeah, and in the interim, Osama put something on the calendar to for today to discuss I think the detailed status for some of the projects going on. To me, it makes sense for you to go first, and it sounds like with your projected 20 minutes, there'll be sufficient time for Osama to cover the detailed status. That's what makes sense to me. Osama, does that sound reasonable?
Yeah, sure, that's fine.
Okay.
It's 2 projects, of course. If it doesn't work out, we can drop the tested TLS project to some other meeting. So that's fine.
We've demonstrated we're really good at trying to cover too much and continuing on a subsequent in 2 weeks. So we that muscle is well exercised. So I think we're in good shape there.
Alrighty. So then, without further ado, let me get started on this. And I will zoom right through it. Actually, it's 8 slides plus a title slide, so even
Perfect.
faster.
Thanks, man.
Sweet. Okay. So can you see my screen?
Yes.
This is our update and it's dated. Okay, so first, this slide, I will send a link to everyone after we're done so you can follow because there are hyperlinks here. So on the top is a link to our charter. And the charter starts with actually explaining what governance is. Turns out that there are as many opinions about what governance is as the number of people that you actually ask. And then we're going to focus on the first thing. So you need to be able to articulate the state of the system. So basically, you have a system, you'd like it to be a certain way and not another way. And then you need to basically specify what you're going to do if it goes out of policy, or it becomes a disallowed state, and everything else is basically keys off of that. At the bottom, there is a link to our current attestation governance patterns document, which is very close to what we are going to be discussing today. I'm just going to basically walk you through it without walking you through it. All right, so here we have the desired properties of attestation governance patterns, right? So you can read from the slides. So I'm just going to provide sort of the overlay. So what happens is we have multiple participants in the space, and what we need to do is we need to align their expectations, right? So if you're a customer, then you have certain expectations of certain parties, and actually have it all in a nice diagram later on. If you are a provider of services, well, you have certain responsibilities, but also certain expectations. If you are a silicon vendor, right, you have mostly responsibilities. Right. If you're an auditor, and you go audit multiple customers, well, if every one of them does things in their own bespoke way, ascertaining compliance and certifying that they're doing something correctly becomes very, very difficult. So we have auditor handbooks in the regulated space that basically tell people, auditors, how to do audits, and also prepare the customers, like regulated institutions, to those audits, because they will know exactly what auditors are looking for. So basically, my observation when starting or convincing the CCC to start the governance SIG was that your main customer is going to be regulated industries, and nobody was talking at the time about what regulated industries actually expect. So that's what we're doing, and I assure you, it's not glamorous, but it's very necessary. All right. So when you talk to people who formulate or deal with the regulators. I talk to the folks who work for my employer who deal with governments and regulators a lot. The absolute for high order bit, the first priority is we do not want something that is technology agnostic, because technology evolves, and we need something that is stated in ways that does not force us down a particular path. So what does that mean? Well, your governance patterns and your regulations are not going to say thou shalt use TDX or SCV or SGX or TPM or XYZ. That's not going to be the case. Now, it will normally say things like at the top level, you have to protect your data at rest, you have to protect your data in transit, and they will say, use encryption, manage keys. Confidential computing itself even is a kind of technology, but that one's almost sort of sitting on the cusp. And the reason is that it's sitting on the cusp is because the alternatives to the ultimate goal of protecting data in use doesn't really have competition outside of confidential computing. Now, what might replace confidential computing as data and use protection technology is kind of an unknown. And but at the same time, it is much better to say protect your data in use than it is to say use confidential computing. And if confidential computing happens to be the only technology forever and ever that can do that, well, then it's still better to just say protect your data in use. Everybody knows what you're doing. So provider and vendor agnostic, again, much like you cannot say use TDX or SGX or use Enclave or confidential virtual machine, you should not say use Microsoft or AWS or Intel or, pick your name. Wide applicability is, again, if you look at confidential computing, there are two things, and maybe more, maybe I'm missing something, but the hosting of the attestation verification service and ownership of devices, will fall into these three categories: that either you own the service, or you own the device, or it's going to be your cloud service provider at some sort of data center. You don't own it, you run your workloads there, or maybe some third party. So for instance, Intel Amber becomes in that case a third party. Comprehensive is that you really want to cover all the big bits because if you don't, that's where ambiguity lies. And ambiguity makes it difficult to pass audits. It creates arguments. It makes things just difficult to deal with. All right, so here I have my really pretty diagram. I'm very proud of it. When we're doing a review, people were saying, why don't you just replace it with a table? But we never got around to it, so now we're stuck with the diagram for the time being. But you will see that there are all these participants in this computational computing space, and they fall into different, several distinct categories. Let's work through the countries. There are the component vendors, right? So component vendors are, in this case, I kind of mean silicon vendors, but these are the people who make your CPUs and your NICs and your devices, and they are, nobody expects, they can't expect anything of anyone necessarily, but they people have expectations on them. Effectively, everybody else has expectations on them. Now, we can go through all these arrows and, try to specify exactly what those expectations are in each case. But you can see that, if I run my, AVS, well, I certainly expect certain endorsement values and keys, etc., to be provided by the component vendors. I expect them to keep their signing keys secret. I expect them to notify me of breaches, and there are all sorts of expectations. We can write them all down. Now, if I'm an owner of a computing device, well, I have a responsibility to AVS owners. Actually, it turns out that responsibility is bidirectional. Again, we can talk about reasons why. I expect certain things of my component vendors, but I'm also responsible to my data owners. And everybody responds to auditors. So bottom left, auditors rule the roost. Now, the governance patterns will be capturing all these responsibilities, and we will suggest sort of effective and reliable ways of addressing these responsibilities, and that's what we really want to capture. Now, you can see lots of arrows on this diagram, means lots of responsibilities, lots of things to dissect, lots of conversations to have. So we're not going to do that now, but this is sort of outlining the space. Next slide. This is, again, if you are in the governance space, I put together this entity relationship diagram, so kind of a universal language, and I color-coded. Now, apologies to someone who is colorblind, but I will walk you through it. So control specifications are the big rectangle on the left. Control specifications are things that generally are in the domain of standards, documents, and contracts. So this is the technology agnostic stuff, completely technology agnostic. So you can have contractual obligations. So because you're operating on data from Boeing, you may have a contractual obligation to safeguard their data or whatnot. Regulatory obligations are to the folks like the financial regulators and basically generally government entities. Which are separate from industry standards, which industry standards may be domain dated by governments, but like CSA, Cloud Security Alliance, or PCI, those are industry standards. Internal policies are, a company may just have its own policies that it puts in for its own use. We lost you there for a moment, Mark. Connectivity, sorry. At which point did you lose me? So we can rewind.
Starting on control objectives again.
Oh, control specifications. Okay, so control specifications, stuff in blue, left-hand side. So going top to bottom, contractual obligations is between you and the customer. So I work with Boeing. Boeing has some airplane designs. I'm responsible to Boeing to not leak their airplane designs. Regulatory obligation is to a government entity, so some sort of financial regulator or insurance regulator or healthcare regulator. They're usually bound to a government of some sort or a region. So GDPR would be regional. California has New York, federal, Singapore. These are all regulatory obligations. Internal policies are within the company to itself. So we may decide that we have highly confidential data and it has to be protected differently from regular confidential data, even if no regulator demands it. And finally, industry standards would be things like PCI, CSA. They are specified by cloud industry or payment card industry or whatever. Sometimes mandated by regulators, but not necessarily. Now, your control specifications, they will form what are called your control objectives. Control objectives are still technology agnostic, but control objectives will be things like, you need to protect your highly confidential data while in use. That would be a control objective. And they go a little bit more detailed than that, but you can see how all of these control specifications on the left go into this box in green, which is control objectives. And normally they will compress down many things that can be implemented by the same control objective, or addressed by the same control objective. Rather, it's not an implementation thing. There in yellow, control procedures. Control objectives expand to control procedures. In order to achieve a control objective, there will be a number of control procedures that I need to implement. And that is sometimes technology specific, so not could be subject to governance patterns, but will never, control procedures will never be part of your standard of any kind, because they're just sort of, this is how you do this thing in this context. And finally, on the far right, implementation steps, completely technology specific, and will be very much done at the, and changes, technology changes. So we will be working with CSA, NIST, etc., on the left-hand side to influence these things like industry standards and regulatory obligations. We're hoping to work with you guys on control objectives and control procedures and patternizing them. And implementation steps we will never touch. All right, finally, not finally, I'm coming halfway through. So we drew this diagram on the right. So let's walk through this a little bit. So, and I think, while I still have your attention, we decided in the governance SIG that we can govern, we can govern the attestation service, and that's a separate section. But when it comes to governing what actually executes on some device and protects some data in use, we can cover what we call a payload slice executing inside a trusted execution environment. The trust execution environment runs on a component of a device. And we'd never govern the entirety of application, because all these individual payload slices, they need to, in fact, secure their communications with all their peers, all their clients, all their servers, etc. But at the granular level, we say, okay, an application will consist, and this is, by the way, there are some differences. There are some differences in the way we use terms, and we need to harmonize the use. Otherwise, we're creating our own domain, and then we'll need translation layer. It is much better that we get together and define a common terminology, but that's not it. This is not it. We will need to change it. We will need to have a conversation. But in terms of this terminology, application is this whole shebang. Application is something that protects, basically operates on some data. It is split across a number. So an application executes a confidential payload. That's the part of the application that actually needs protection of data in use. The payload is split across slices. Slices run on T's, and T's runs on components, and components make up devices. That's what this diagram is trying to address. Everything in the rounded box is governable. So a component might be governable, although a component might host multiple trust execution environments that are in fact mutually distrustful. That's sort of what's going on. And we will need to make sure that we actually have, again, what we mean by trusted execution environment is more akin to a firmware of a virtual machine, turns out, than anything else. And again, that's a very subtle discussion. We can't have it here, but I would like to schedule some time after you guys go through our governance patterns doc, to finesse some of these terms. All right, and over on the right here, the attestation verification service. Well, there's a bunch of governable stuff about it. The keys, which are many different kinds, I'll show on the next slide. The various policies it has, the various logs, all subject to governance. All right, so here what we have is a picture of, there is a attestation verification service infrastructure with some central keys and some central policies, and it creates logs related to infrastructure that perhaps keep track of, who made what change to what policy, what keys are in effect. The logs themselves might be protected with those keys, and so on and so forth. And then in a general case, an attestation verification service will have multiple mutually distrustful tenants, each tenant with its own keys and policies. So for instance, if your attestation verification service is Microsoft attestation service, then Microsoft has the infrastructure and governed infrastructure. It is responsible for that bit. But as a tenant of Microsoft attestation service, I will probably want to have my own signing keys, my own encryption keys, my own policies related to my stuff. And I can't have any other tenant mess with my stuff. So that is, again, lends itself to governance patterns. All right. So finally, what I want to talk about is this popping up a level outside of attestation or confidential computing, but patterns themselves, they kind of have a language. And the hyperlink here is to a folder where you can read 4 papers on how to write patterns. Now, I can vouch that this is very, very powerful. I used them at work for creating patterns around enterprise architecture for my employer. But here is a diagram here that every pattern has a few required components and a few optional components. And I explain them here. You can get them in more detail inside the documents. I highly recommend that you look at this, because if we're going to be working on authoring patterns. By the way, the current document, it's called Attestation Governance Patterns. It's not written in patterns language. So I just want to make that clear. So what we want to do is agree on the content of the doc and then go rewrite it. Now, how many patterns are we thinking? Well, we're thinking at least 9 split across 3 groups. And we split them into baseline governance patterns, attestation verification service governance patterns, and downtime minimizing deployment governance patterns. Now, there may be others. We probably haven't thought of anything, so this is not a fixed list. Baselines have to do with, what is my confidential payload, and what do I expect of the trusted execution environment where it executes? What do I expect of the components of the infrastructure on which these trusted execution environments got started? And all of them, turns out, have separate patterns that could be specified around them. Similarly, the attestation verification service itself requires the governance of the tenant, of the service, and of the relationship between the attestation verification service and the relying party. So this was actually something that we discussed in the SIG, maybe a month back, where we talked about, so what should the attestation verification service say such that the relying party can understand what it's saying, right? So you could basically have attestation verification service sign all the measurements and have the relying party make use of it, make sense of it. Possible, probably not the best thing you can do. Or you can have attestation verification service give a binary assessment, and that relying party will be either say yes or no. Turns out not ideal either. So this is where we started talking about things like issuance policies that gets satisfied and signed. So relying party can say, oh, this payload is in a place that satisfies my highly confidential data. Issuance policy was only be issued if highly confidential data can live there. These sorts of things. So we need to figure out what these patterns are and split them, document them individually. And finally, if you're going to avoid outages, the way you deploy your payloads versus T's versus components are all different. And we can have separate discussions and document separate patterns about what do I do as a manager of data center infrastructure to minimize downtime to my customers, etc. That's really it. That's my presentation. We're at the bottom of last slide. Welcome your comments, so we can have an offline discussion. I will share this deck, and you will have access to all the hyperlinks.
Thanks, Mark. Once again, very insightful. I've got one immediate question, actually two, I think, and one is, what audience is going once these are done, once they get to a point where I guess maybe they're never done, but once they get to a point they've met some criteria, are these going to be, who's going to consume them and take what action based on them? Is this going to be something auditors look at and start asking for, or what?
Okay, so this question can have multiple answers. I'll give you some, probably not an exhaustive list. One answer could be, and in fact, there is for context. you will probably need to write this one down. There is in an area very much related to this. NIST has a preliminary draft out around zero trust architecture. It's called Special Publication 1800-35. It's in 5 parts, A through E. In SP 1835E, you will find a mapping between zero trust architectural components and the NIST cybersecurity framework. So there is an entire document that says, your policy engine satisfies these CSF statements. Your policy administrator satisfies these statements. Your just-in-time access, this and this and this. And it basically says, look, if you implement these aspects of zero trust, you will be in compliance with the NIST cybersecurity framework, and basically checks off all the sections. So eventually, it would be nice to have a mapping like this between architectural building blocks of confidential computing and things like CSA CCM or NIST cybersecurity profile or the NIST cybersecurity framework. And then you can basically go down the line. And again, it will take more people than ones on this call to author it all. But if you have a comprehensive set of documents from the Confidential Computing Consortium that says, this is how you govern these systems. We can then draw lines between that and the various expectations that particular regulators place on various participants in that system. And again, this is tedious work, but this is how the sausage is made. And what we will hoping to do is take these patterns, and we're already working with CSA. And we are hoping to engage NIST, and we're reaching out to organizations like CISA, ICO in the UK on privacy enhancing technologies, and so on and so forth. These guys don't know confidential computing. They just know that they would like to secure or help secure and provide guidance to people in the field. So if these documents exist and are of high quality, then what ends up happening is they get picked up by these various organizations around the world to become part of their corpus. So that's the best I can give you, like a short to medium term.
Yeah. Okay. I think I'm grokking it a bit. I think it's the way I'm interpreting it is, the players in kind of the auditing space or the regulator space, back to one of your diagram on slide 6, if you quickly click on slide 6, maybe I can say the right term. So the folks creating regulatory obligations, the folks that want these things that are expressed in ways in the blue rounded rec, if everybody kind of agrees that these architectural patterns that are going to be defined are ways to satisfy these things, then it makes it easier for everybody to know, to address them. It makes it easy for folks who define them to say, oh, you did these things, it matches the pattern which we've reviewed and accepted, so you're good. And vice versa, if you're trying to meet these things, you can say, if I do these patterns, then I can kind of see, look at the things that it sprays out and covers these regulatory obligations and these industry standards. Okay.
So where I work, we have a system. You may have heard of it if you work for a regulated institution. It's like a vendor system, but it's called Archer. And in Archer, it's a corpus of knowledge that where an organization will document all of this stuff, and it really does have standards. Some of them are industry standards, some of them are standards we define, like what does it mean for us to have an architectural decision record or whatnot. And it does specify control objectives. They're all numbered and they're browsable in this UI. And it will tell you what the control procedures are. It will tell you what the implementation steps are. And a regulated institution will document all of this stuff. When auditors come in, we will show them what we are aiming to achieve. It's all there in Archer, and we then we're held accountable to these written statements, and how do you author them? Well, you're hoping to get a good source of information that helps you write the right objectives, procedures, and implementation steps.
Cool.
Yeah, it takes a certain temperament, I'm telling you, to deal with this space, but also we can devise the best technology out there as engineers. I'm an engineer, and it will not see the light of day unless we can translate it into this type of language.
Cool. Thanks for answering my question, Mark.
Yeah.
Any other questions or any final words, Mark, before we move on to Osama?
No more words. I will email the link to this deck. If you have problems accessing, just request access. It's on Google Drive, and I will make sure you have commenter access. And then all comments, I promise you, all comments will be individually considered and addressed.
Are you okay uploading it to the SIG's repo?
Yeah, if you send me instructions, I will upload it, or I can just
right.
I can just email you the link and whatever. Like we'll figure it out. Yeah.
All right. Yogesh, you had your hand up for a second.
Yeah, I thought no. Yeah, I just Mark. In terms of the implementation steps, how would tangibly that implementation is complying to these obligations? How one can measure, and are you going to publish some kind of?
So implementation steps would have to be literally at the level of a technology. So implementation steps for Microsoft Azure attestation is going to be different from AWS attestation, will different from Google attestation, right? So if you have a control procedure, the control procedure will say something about, you need to back up your, I do not know, policy logs every 30 days. That becomes your control procedure. That's it's one of the things. But how you do it would be in the context of which cloud you're operating on, etc. And control objective might be ensure that the attestation logs are preserved.
And
you can imagine that these are pretty like our control the objectives and procedures, they number in the thousands.
Yeah. Could potentially explode, yes.
Well, I mean, it kind of has to if you're going to actually capture everything. And in my case, I work for a bank, so this is the kind of stuff that keeps your money safe.
Sure.
You're assuming we have money.
Oh, what's left of it.
All right, cool. Thank you, Mark. Osama, are you ready to discuss the status of some of the projects?
Yeah. I'm ready. Just a moment. I will share. Okay, so I hope you see the slides now.
Yeah, I see the slides.
Okay, awesome. So I will just move this one. Okay, right. So I wanted to talk about two projects, and I think I will have time only for one. So this is the one on formal verification, and joint work with Thomas and Simon. And I will quickly just go through some of these points, because some of them I already covered when we were discussing about TDX update. So the plan is to go about describe in a few words this executive summary of where we are standing right now. Just reiterate on the approach. Of course, it's just the same as we have used for TDX. So just to remind the people. And then verification challenges, specifically, this will only be focusing on the updates for CCA, ARM CCA. And then finally summarize and move on to attested TLS project verification if we have time. Right, so where we are at the moment. So Intel TDX, which was one part of the project, we have discussed it on 6th June. Slides and video links are available in case you have joined later. Some new people have joined after that. ARM CCA, I will have a demo today, And AMD, SCV, SNP, as I described last time, so University of Zagreb is actually working on this, and then we will see how to go about this. They said like in 1 month they will have something around this, and we are discussing on how to collaborate on this. Okay, and the work on formalization of attested TLS project is already initiated, and I will have a few description of that if we have time. A couple of drafts already. The first one that is already out since January, and the one which is now specifically focusing on this work, which is namely the formal verification part, is to be available soon. Okay, so this is the overall status where we are. And as I said, I will now just briefly recall about the approach that we had used. And in that specifically, just a very high level picture of that is that on the top, we have these transport protocols, for instance, SPDM or TLS protocol. And underneath, we have this what we call as the architecturally defined remote attestation. And in that, so specific to this project, in the scope of this project, keeping AMD aside for a moment, so Intel and ARM, inside Intel, so the two solutions, SGX and TDX, as you all know, so SGX is based on DCAP and APID, anonymous attestation and third-party attestation, and TDX building upon SGX and using DCAP. And on the right, this is the platform attester, and this is the RAM attester. So this is in comparison to Intel, a different technology altogether. So now I have a couple of other things just to visualize how these technologies can be thought of. So for example, the granularity at which the isolation is done, SGX process-based, TDX and CCA both VM-based. And then a significant difference between the two similarly is that Intel has its deployed products from verification perspective specifically, and ARM has architectural specifications. And on the basis of these specifications, one can build a number of solutions. And then how do we go about building these or verifying these specifications is different from how I will verify a deployed product. So this is one major difference between the two. And from the attester perspective, as I said, so SGX and TDX both are building on a layered architecture, starting from the hardware up to the application. On the other hand, this ARM CCA platform attester and RAM attester, as I will show in one of the next slides, is a composite attester as per RAT's definition. So this is this of course needs a bit of refinement, but this gives you an overall idea of how these technologies are different from verification perspective and otherwise. So the reason of having this was to give you a top level view of this project, which is actually focusing on this specific part, which is TDX, ARM CCA, for now at least, and then we might have AMD, something in discussion. It's covering almost all of the domains. So for this part, we already have formalizations. So it's already this process-based, it already covered. And this part is already covering a lot of domains, different parts, that is also covering the VM-based technologies, also covering the deployed products, architectural specifications, layered and composite. So this combination in itself, even though, let's say, we do not cover AMD, for example, we have all the basic building blocks that we need to cover any technology which will be, so we only need the certificate chain, how it's going to be built, and then we need to, then we can adapt the verification accordingly. So this basically was to show a top level view. And then this transport thing is the connection between the two projects, which is this architecturally defined attestation and combining it with the transport protocols, which is also the third project, which is by Intel. So this is Intel in some of its transport protocols is using also SPDM. So that's why I specifically mentioned it. And then ARM's proposal, that is the attested TLS project, specifically proposing a specific way of how does this CCA, for instance, can be composed with the TLS protocol. That is one specific part of this as a server, as an attester. I will come to that. Anyway, so within the approach now, we have segregated, let's say, the architecturally defined attestation, and then the TLS on top, that is the relying party and the connections. So architecturally defined attestation, so now is only defining what's the minimal between the attester and the verifier. And the minimal means that the protocol details are eliminated. And here is the attester. So this part basically coming out from the RATS architecture. And the additional thing is this identity supplier supplying the identity to the attester. That's part of the attester provisioning. And with this, we cover holistically all the phases, which means that the provisioning, including this attester provisioning, this identity, and the verifier provisioning, providing it with all the endorsement and the reference values. Initialization, the starting steps which are needed for the attestation protocol to run, generating some keys and so on. And the actual attestation protocol, which is that how do the verifier and the tester share the data, the attestation challenge and the evidence coming back, how is it signed and so on, how is it protected, and maybe some local steps within the attester which is not described in the RATS architecture itself. So which is indeed a primary thing for local for a requirement for a remote attestation of Intel SGX and TDX. So what we do is we define a prefix for evidence, local, meaning that it's local to the attester, local evidence, and then the remote evidence, which will be going out of the attester to a remote party, can be a verifier or a relying party, for instance. So we have, as per RATS, all the same except this new entity that we have added for anonymous attestation in order to cover Intel APIT architecture. Okay, so coming to the contributions, specifically the T-agnostic verification approach, meaning that the T-agnostic architecture combined with the formal verification is something which is the main contribution of this work. In our previous work, for instance, we did verification of Intel, SGX, APIT, and DCAP, so that was a specific technology. And as I showed you on the first slide, so there is a wide variety of different things, and it would be very tedious to do the verification for each and every one of them. So what we propose is that a division of the responsibilities, basically. So the vendors provide this T-agnostic architecture, map their solutions to this T-agnostic architecture, and then an auditor or a verification engineer can, for instance, then verify the solutions based on the given specifications. Specifically for CCA, this is the first formal specification analysis of attestation in its group, meaning the architecturally defined, the group of architecture lead solutions. And for TDX, in our previous work a couple of years ago, we had in analysis of TDX, and this one is actually adding a lot more details, including the certificate chain and all the verifier steps that a verifier needs to do in order to do that. And we also add the initialization phase. And in this case, the measurements are variable, meaning that an attacker can change the different measurements, and then the verifier has to judge whether it's correct or not. For instance, MR enclave, MR signer, and so on. So it's much more realistic as compared to the previous one. So we have a formal proof of insecurity of Intel's claim TCB, and we have substantially improved the Intel specifications. But I will not go into details of this. So this is this presentation will focus, or is designed to focus more on CCA. And we have our open source artifacts available on the CCC Git repo, as you all know. So a couple of use cases. Attested TLS, as I said, so Siemens, ARM, Intuit, Barkhausen Institute, in collaboration with them, we are basically using the same artifacts that we have developed for CCA in order to be used with the tested CLS. So essentially the trusted execution environment that we will take for the verification will be basically CCA, and that's basically connecting the two projects to be used inside this. So this will serve as the base of, or the foundation for formal reasoning in this project. So that's the link between the two. And Intel requested us that they also want the verification of the VTPM solution. That's what we are working on, and that's basically using these artifacts of TDX that we have developed and building upon this. And it has a lot more details. So it's then adding SPDM, and then there is going to be a combination of the two. So essentially it's reusing this part of TDX and then building the solution on top of that to merge the two. Okay, so formal methods, just a recap, quick one, are mathematical techniques which guarantee that a model that we build satisfies some set of requirements. And probably I forgot to mention, so if you have any question, feel free to interrupt. I will not be looking at the chat. So Greg, if there is any question or comment, so maybe you can speak up then.
Yeah, I'll chime in. I'll chime in if I see something.
Perfect, thanks a lot. So formal verification, as I described last time, we have a system and a property, and what we want is to see whether the system satisfies this property. And in this specific case of, we have a protocol in the presence of an adversary, that's an additional role, and we still want this property to be satisfied. So essentially we have here a security property that we need to satisfy, a protocol like TLS or attestation, architecturally defined attestation, as I said, or a combination of, or a composition of both protocols. And we want that in the presence of a specifically defined adversary, a specific property is satisfied or satisfied or not. So that's the question that we want to answer using formal verification. So quickly, there is a system. We build an abstract model in a precisely defined language with clear semantics. And we have requirements that we want to satisfy, some security requirements. We define them formally as properties. And then what we want to check is that whether this abstract model satisfies this property or not. That's the part of this verification. Right, so we have in the approach, as on this slide, so there are three main things: the protocol, the adversary, and the property. So these are the three things that I will now describe, specific relation to the ARM CCA, the properties, the model, and the threat model or the adversary model. Okay, so the properties first. Very, very simplified high-level figure of this. So we have a verifier, a tester running in the cloud, and verifier sends an attestation challenge. It generates, does all the processing, sends an evidence, and after verification, the verifier sends over some secrets or sensitive data. So very abstracted. What we want to have here is, from a formal perspective, first, sanity checks, because in the last figure I showed that from the system we have an abstracted model. So by abstraction, how are we sure that we still have kept all the details? So these are the sanity checks which are checking exactly this. Integrity is important, that the evidence passing through this cloud and the network is not modified, is the data or the important fields, for instance, inside the evidence are not modified. The measurements and the identity fields, for instance, are remain the same. Freshness, that every time the evidence is obtained, it's not possible to replay it. And then the confidentiality or secrecy of the secrets. So in the context of architecturally defined attestation, because we do not have a shared secret now, that comes from the TLS, and that's why the confidentiality here will mean the, sorry, is there any question?
I do not know how deeply you want to bake a lack of replay into your architecture. Let me explain why. whenever you have a challenge on the in this protocol, it requires that your verifier maintains state. State can be difficult to do if your verifier is distributed and if you have sessionless communication. And in fact, if a tester basically says, this is the key I'm keeping in my whatever T, I do not know if there's always a security vulnerability related to replay. In fact, there is possible to construct a protocol as a proof of concept with a TPM that basically says only a machine in this state of PCRs will be able to decrypt this response. So then you can basically omit the nonce from the exchange at all. In fact, I was going to recommend to the attestation SIG that we consider removing nonce from protocols if possible. But other than that, that's the only comment I have.
Yeah, right. So from this perspective, at least, what we are doing here is the attester is, or the way it's also done in TTX, SCX, and also CCA, is that the signatures actually cover the nonce coming from there, and that's providing basically the freshness of the evidence. And because the clock is not trusted, I do not see what other method you can use, for instance, as a replacement of this nonce, if the vulnerability that you are mentioning, for instance, is realistic or is real. Do you have any alternate proposal? What else to use? Like, I mean, in the confidential computing proposal or the model that the clock is not trusted.
So the RATS architecture has 3 example categories of freshness stuff. And just for completeness, I'll list what those are. There's the non-stuff that Mark is talking about. There's using synchronized clocks, timestamp stuff, which is stuff that you're talking about, Mohammed. And then the third category that's in there is the epoch ID. And so the RATS architecture doesn't specify protocols. It says that protocols tend to fall into one of these 3 categories. And so since you talked about two of them, and you said, are there any alternatives? I just wanted to point to the epoch ID discussion in there, that somebody could design a protocol that fits in the epoch ID category. And it's, roughly speaking, it's, since I don't think Henk is on the call, right? Henk was the inventor of the concept, at least as far as I know anyway. He's the documenter of it anyway. And so the concept is, instead of having like a time server that generates time for things, you just have somebody that generates not quite nonces, because nonces are one use, right? They're just a unique value every so often. Okay, and so as long as both sides have the same unique value, then they know that they've gotten that value from somebody within the same epoch, and so your timeliness is whatever the frequency of the epoch distribution is. That's roughly. You can read the details in there, but that's the third category that does not require synchronized clocks. It does not require nonces in the actual protocol. Per se, in terms of one-time nonces, because you put the epoch ID in there instead, and the epoch ID can be reused. It's not a one-time thing. It's continue to use it within whatever the epoch is. So if your epoch is 15 minutes, then of course you can reuse the same value for a 15-minute period and so on. So it's not like a nonce in that category. But it means that your granularity of how fresh it is limited to whatever the epoch distribution period is.
Dave, so sorry to interrupt. I just want to ask about that. So what Mark was mentioning earlier is that maybe there would be a point in time where the verifier will be stateless, and in that proposal of using an epoch ID, it means that the verifier will need to contain a state.
The verifier is not stateless because it keeps, for example, the appraisal policy for evidence, and so that's state, right? So what we mean by stateless is it's not a per request state, and the epoch ID is not a per request state.
Okay, yeah, I see.
Nor is it a per client state, for that matter, right? Because you could say all attesters that are using the verifier use the same, epoch ID distributor. And so it's not a per attester state either. It's more like the appraisal policy for evidence, which is it's one common global set of state.
Yeah, I'll throw another consideration, which maybe I'm talking out my ass, so forgive me. But We've seen cases where it is important to do attestation kind of in a rear view mirror. So for instance, you're writing a log and you want to make sure that the log has originated in a proper trust execution environment. So you may want to create a quote over what happened at the time you generated this log, or maybe you are streaming some data from a confidential camera, but you're buffering it. So by the time the stream gets processed, well, the world has moved on, and you're basically looking at a state that has been. And then what you need to do is you need to perform attestation to ensure that the device that generated a statement was in a good state at the time that the statement was generated, even if the world has moved on, right? In which case you may maintain some sort of history of what policy. So this epoch ID seems like, the best for this type of thing. But if you basically saying your attestation protocol depends on a nonce and things being current, you're basically making it impossible to do certain very interesting things.
Right. I think this is an interesting point. So epoch ID I haven't considered, and neither is in the solution of Intel or ARM. So, but I have seen some releases contract and something like that, some papers based on that. Theoretically, I think it should be possible to use use these, but I don't have a very strong opinion on saying that epoch ID will be strictly better than using nonces. So I will do some search and then maybe next time I will update on that. So that's a good point. Thanks for sharing.
If that can help from the CCA perspective, there's no difference using one or the other. Nonce or epoch ID are equivalent from that point of view. We can discuss this further, I think. I will need to do that.
Okay. Mm-hmm.
Although there's semantic difference, there's no actual difference in the way it's used and consumed by the verifier and the attester. So.
I just pasted the link to the concrete proposal, which isn't an RFC. That's the write-up for one way of actually implementing it, and acknowledgement. Thomas is a co-author. So, thanks, Thomas.
Right. Thanks.
Thank you, Dave.
Hey, Osama, just one quick thing. Time check. We're at 4 minutes to the hour, so. If you could possibly find a good breaking point in a couple minutes and leave us a couple minutes to coordinate the next meeting, that'd be great.
Sure. Right. So thanks. I think that's maybe the last. Okay. So the authentication then is different from integrity. That's so which is related to the data, and this authentication property is related to the data origin, meaning the verifier or the attester that the other party is correct, the one it's communicating to. So these are the relevant properties that we have verified or analyzed. Other than this, so this is only checking, and the 4 properties that we have analyzed. And I think I will stop here probably because the model will then take some time to describe, right? So then maybe this is a good point to stop if someone has some comments. So we can have a short discussion. Yeah.
So thanks, Osama. Since you're not complete, are you able and willing to continue finish the deck in a couple weeks?
Just a moment. Let me check quickly. So yes, yeah, that's fine.
Okay. And then there was also, I think, proposed for today, the other topic, attested TLS, form of verification of that. Is that also to be something that would be part of the next couple weeks from now?
Yeah, I think we will make some progress on that. We are already working towards that. So both of them I can maybe merge in together in one, the same presentation.
All right. Any questions for Osama on what he went through today? Well, that was certainly enlightening, Osama. Thank you for sharing that. Once again, I picked up a lot just listening, and every time I see it, I get a few more details. And Mark, also similarly for the architectural prototypes or templates, that's also giving me food for thought. Mechanics for the meeting a couple of weeks from now. We have a couple of the chairs on the call. Do we have a volunteer for chairing in 2 weeks? That would, I think, be Thomas or Jim. Jim's still here.
Yeah, I'll be on vacation in 2 weeks.
Okay.
On that Tuesday, so
Okay, I'll take it.
Thomas, did I hear you say you'll take it?
Yeah, if Jim is out, so I
Okay.
think Keith is also out, right? And he doesn't.
Yeah, well, he's out
for you
today,
to
so
take-
yeah. Okay, cool. So we'll put your name on the next one. It sounds like we have a fairly significant chunk of discussion to go through with Osama's conclusion.
Yeah.
So I'm not sure there's a room for anything else. I guess one thing I wanted to discuss, and there's no time now, but perhaps it fits in well next time, is to do another kind of brainstorming round with the community as for where we kind of stand with topics we want to talk about and additional ideas. We're kind of at the end of the previously discussed backlog, and we had a few different tracks that we were thinking about, composite attestation and information models and establishing a secure channel. So I think from my perspective, it'd be worthwhile to have a chat about those topics, those tracks, if there's additional tracks we want to look into, and just brainstorm a bit about what direction we're going and how we want to continue.
I have to jump. So I really want to ask a question and not stick around for the response. So Greg, perhaps you and I can talk offline. I'd like to understand how we're going to proceed on attestation governance patterns. It doesn't have to be next time we meet, but I would like to request a review of the document, some comments, so we can start moving in reconciling.
Okay, I hear your request. I think the request is for folks to review the document. You share the link and provide any feedback and comments in the doc, right?
Yes. So, and then schedule some
Okay.
time for us to get back together and start talking about the
Okay.
details. Yeah. Thank you.
Okay, cool. Thank you. All right. I guess that concludes today's conversation. Thanks everybody for showing up today, and we'll see you in a couple weeks.
Thank you. Bye-bye.
Bye.
Thank you. Bye. Very nice discussions. Bye.
Take care. Bye.